class, onto linear versus non-linear relations. Stop right now if you have not done yesterday's homework or indeed yesterday's lesson. You must do that first to have an understanding as to what is happening here. I've also posted solutions to the homework from last night, along with a video that shows me talking you through how I got those solutions. So please be sure to check out those first. Welcome back. Looking at a relation that looks like this, y equals x minus 3. I have a table of values, so I need to complete it. This is often a task that I would give you as a quiz question. So this tells me that x can take any values that I choose, and I've chosen the values -2 through to 2. So I would replace x in this equation with this value here in order to figure out y. Y is simply equal to x, which in this case would be -2, minus 3. And -2 minus 3 is -5. And you would do that for each one. So the next one would be -1 minus 3, giving us -4. The next one would be 0 minus 3. Do you get the idea? And we just keep on going down like that. And you can use a calculator for this if you're not confident with your in-head skills. And then you end up with these values for y right there. You don't necessarily need to show your work. I'm just showing my work for this now so you understand where it comes from. On to this relation, y equals x squared minus 3. When x is -2, this is where you have to be careful. It is not -2 squared. We have to make sure we put a bracket around that -2 before we square it. It makes a difference in the final answer, because that gives us 4. -2 times itself is 4. 4 minus 3 is 1. This one would be -1 squared minus 3, which would give me 1 minus 3, in other words, -2. This one, 0 minus 3, -3. Now, when we get positive numbers, you don't need the brackets. 1 squared minus 3 is just -2, and 2 squared minus 3. 2 times 2 is 4, minus 3 is -1. Now I'm asking you to graph these two relations. So what I'd like you to do is press pause in a moment, and I'll explain first what you are graphing. You are going to take these values of x and their matching y values, and you would plot that as a coordinate. So this one, for example, would give you the coordinate -2, -5. And on my graph here, assuming that these boxes are one unit along, -2, -5 would be a point right there. And you would plot that point. And I want you to do that for all of them. So this one, next one will be -1, -4. And you would plot that one, -1, -4, and plot the point. I'd like you to do that for all the points and come back to me in a moment when you're finished to see if yours matches mine. Please press pause now. Okay, welcome back. Your graph should look something like this. I decided to join the dots. You'll notice that when I'm doing this graph, I don't join it with a straight lines like a connect the dots puzzle. I just join it with a curve as best as I can on a computer. Now let's look at first differences and second differences for each of these relations. So you're going to take these values that you have in the y column and repeat them here. Okay, and once you have them repeated, we're going to calculate the first differences. So what does that mean? That means a change in y. So how did -5 become -4? What did we do to it? Well, we've increased it by 1. This one, from -4 to -3, increased by 1. And so on. Keep doing it for each of these differences. And then do the same with the next relation. You'll notice with this one, as we get further down, it's doing a few weird things, right? Where it's not the same. What you will notice with this relation is that the first differences are all constant, what we call constant or the same. Whereas with the second relation, these are not constant. Let's take a bit of an overview as to what we have here. Clearly, the relation on the left side is a linear relation. What do we notice about it? Anything special about the table of values? Well, not really, but when we plot them on a graph, we can see that they clearly form a straight line. What we can also see from the first differences is that First differences are constant for a linear relation. Whereas with the second graph, you can see clearly after plotting that the relation is not linear. And also that's indicated by the first differences not being constant. Do you notice a difference in the equations? Take a look at the equations. With a linear equation, you don't have any exponents. With a non-linear equation, you have exponents. Or maybe something weird happening like a square root. But with linear equations, you usually just have a y, you have an x, and there might be a multiple of x and adding or subtracting something, perhaps. So let's define the following terms. What is a linear relation? A linear relation is a relation between two variables that make a straight line and that has first differences that are constant. A non-linear relation, however, is a relation between two variables that does not make a straight line and has first differences that are not constant. Are the previous relations linear or non-linear? The first one was linear. The second one is not linear. Discuss 3 methods to decide if a relation is linear or non-linear. So the first thing would be to do a table of values and graph it. If it is a line, it's linear. If it's not a line, then it's non-linear. The second thing will be to look at the equation. If it is like y equals mx plus b, where m and b can be any numbers, then it is linear. If it has exponents or square roots, then it's non-linear. The third thing to do would be calculate first differences. If first differences are constant, it is linear. If they are not constant, it is non-linear. So let's take a look at these examples and state whether it's a relation is a linear or non-linear and explain why. Well, this one is linear. It is of the form y equals mx plus b, where m and b can be any numbers. And in this case, it's half and 4, and that's just fine. This one, yes, it's linear because you have two variables, c and k, no exponents, and just some integers there as well. This one, no, it's non-linear because of the exponent on x. And that's it, folks. So please go do the practice questions and let me know if you have any problems by connecting into the live check-in. Thanks. Bye-bye.